Section 1.5. Here are your objectives for the day. Solve quadratic equations by factoring. Solve quadratic equations by the square root property. Solve quadratic equations by completing the square. Solve quadratic equations using the quadratic formula. Use the discriminant to determine the number and type of solutions, and determine the most efficient method to use when solving a quadratic equation. Okay? So first things first. Let's work on solving by factoring. Okay? We spent a fair amount of time talking about factoring in Algebra 2. Okay? So if we have x squared minus 7x plus 10 equals 0, how do you solve that by factoring? Do you remember? So what we said was, here's A, here's B, and here's C, right? What did we look for? AC, right? What's AC in this case? 10. And what's B in this case? Negative 7, okay? So we're saying, what two numbers multiply to be 10 and add to be negative 7? Do you remember? Negative 5 and negative 2, okay? When my leading coefficient is 1, we can go straight to the factors. We can say x minus 5 and x minus 2 equals 0, okay? There's actually a property in algebra, in math, I don't know if it's specifically in algebra, that says if A times B equals 0, then A equals 0 or B equals 0 or both. Okay? Well, if that's true, then if x minus 5 times x minus 2 equals 0, which one of them equals 0? God bless you. They both can, right? They both can. So set them both equal to 0. X minus 5 equals 0, and x minus 2 equals 0. Add 5, x equals 5. Add 2, x equals 2. Okay? How do you know these are correct? So 25 minus 35 plus 10, does that equal 0? Okay, so 4 minus 14 plus 10 equals 0? Yeah, so they both work. They're both solutions, okay? So here's the deal. What if A is not 0? Can I still do AC? I meant 1. I said 0. I'm sorry. I meant 1. Can I still do AC if A is not 1? Can I remind you how to do that just using the same problem? Okay. I still do AC and I still do B. But this time, instead of going somewhere else, what I do is I split the middle term into two parts, which was negative 5 and 2, right? I rewrite this problem to be x squared minus 5x minus 2x plus 10. Okay? Then I just look at the first two terms. What's common in just the first two terms? What can I factor out? An x, right? If I factor out an x, I have x minus 5 left over, correct? Now what's common in just the second two terms? A 2, right? But we know that we need our second parentheses to look exactly like our first parentheses. So what do I need to factor out instead of just a 2? A negative 2. Okay? And when I do that, I do get x minus 5. Now I have these two terms right here. 1, 2. What do those two terms have in common? They have an x minus 5. Once I factor out the x minus 5, what's left? X minus 2. So do you see how we got the same things in this particular problem? But do you remember how to do it if you have to split the middle term this way? Okay? So that's what we do if it's a trinomial, right? Well, what if it's not a trinomial? Okay? What if it looks more like something like this? That's just a binomial, right? Is there anything special about each of these numbers? They can be square rooted, right? So they are squared terms. And what sign is in between them? Do you remember what this is called? Difference of squares. Do you remember how to factor difference of squares? X plus 5, x minus 5. Square root of the first term, square root of the last term. Opposite signs. What about 4y squared minus 49? Is that the difference of squares? Yes, that's a squared term, that's a squared term. So I get 2y plus 7, 2y minus 7. Everybody okay with that? What about this one? Is this the difference of squares? Nope, it's the sum of squares. Can we factor the sum of squares? No, it's prime. We cannot factor it any more than it already is, okay? What about this? Is that the difference of squares? No, what is it? Difference of cubes? Remember when I taught you difference of cubes, I taught you a pattern? If you don't remember the pattern, that's okay because I do, and I can show you. Is that all right? So what I said is you're going to get a binomial and a trinomial. Okay? What goes in the first part of the binomial? A. What goes in the first part or the second part of the binomial? B. Right? We get that one first because the trinomial is based on the binomial, isn't it? First term is this term squared. Last term is this term squared. And the middle term? A times B. Okay? Whatever this sign is what this sign is. The next sign is opposite of that. The last sign is always plus. Is any of this coming back to you? Good. What about the sum of cubes? Do you know how to do the sum of cubes? If you know how to do the difference of cubes, then you know how to do the sum of cubes, don't you? Okay? 8a cubed plus 1. Binomial. Trinomial. What goes in the beginning of the binomial? 2a, right? It's a cube root of whatever was there. What goes in at the back of the binomial? 1, because it's a cube root of that, right? So what goes at the beginning of the trinomial? Square that. Like square the whole thing. So 4a squared. And then what goes at the very back of the trinomial? Square that. 1. And what goes in the middle? 2a, right? 2a times 1, which is just 2a. And then what about the signs? What sign goes in the binomial? A plus, because that's what's in the problem. What's the next one? Opposite of that. And what's the last one? Always plus. You remember that? Guys, I promise this is a lot to remember in one day. I know that. Okay? You're okay. Take a breath. Okay? So, how are you feeling solving quadratics by factoring? Feeling okay with that? Okay? Let's work on solving them by square roots. Oops, sorry. Three x squared minus 15 equals 0. If we're solving by square roots, how do we know, first of all, that we're solving by square roots? Is there an x term in here? No, there's only an x term. Excuse me, there's only an x squared term, and then there's only a constant, right? So we want to be able to solve for x super easily, so we want to get the x squared on one side, and then all the numbers on the other, right? All the constants. So what do you want to do first? Add 15. If I add 15, I end up with 3x squared equals 15. Then what do you want to do? Divide by 3. Then we have x squared equals 5. Think about what a quadratic looks like. Think about how many times it will cross the x-axis most of the time. How many answers should we get? 2, right? Most of the time we'll get 2. All the time? No. Sometimes we'll get 1, sometimes we won't get any, right? But most of the time we should get 2, correct? So from here, what do I do? Square root. So what does x equal? If I'm getting 2 answers, think about it. What am I getting? Very good. Plus or minus the square root of 5. Because I don't know the square root of 5, do you? Yeah. If it was a 9, I could take the square root of 9 and get plus or minus 3, right? But I don't know the square root of 5. Okay? Any questions about that? What about if it looks like this? Should I try to like x minus 2 times x minus 2 and distribute that all out? No, I shouldn't. What should I do first? Yeah, just square root the whole thing, right? Here and here. On the left-hand side, I have x minus 2. And on the right-hand side, I have plus or minus 6. When I add 2 to both sides, I just have to think with my brain for a second, right? First of all, I have 6 plus 2, which gives me... Uh-oh. I just messed up. Can I fix it? I just forgot something. Did you see what I forgot? Yeah, I forgot my square root sign. Okay? And that changes what I'm about to do. Sorry about that. Can I put the 2 inside the root sign? No, so it has to go on the outside, doesn't it? 2 plus or minus the square root of 6, and then I'm done. So how do you feel about solving quadratics with the square root property? Good? Okay. So next, solve quadratics by completing the square. X squared. Let's practice completing the square first before we practice solving. Is that okay with you? What goes in the blank? Do you remember how to do this? Whatever this x term is, I'm going to divide it by 2, and I'm going to square it. What's 8 divided by 2? 4 squared? 16. What if it was x squared minus 10x? How do I complete the square? Divide it by 2 and square it. What's negative 10 divided by 2? Negative 5 squared plus 25, right? When I'm completing the square, am I ever going to subtract anything to complete the square? No. Square is always going to be positive because no matter if this is positive or negative, once I square it, I get a positive, right? Okay? Do we divide fractions by 2? No? What do we do instead? Times a half. So this would be 3 over 10. And then I have to square this. How do I square a fraction? Square the numerator, square the denominator, right? So what is this? Good. So still looking at these, remembering about completing the square, I'm remembering about it. Probably you're not, but that's okay. Okay. The next thing we have to do after we complete the square is take it to its binomial. Can you take all of these to its binomial? You remember how to do that? It's going to look like x something squared, right? What goes in this place? It's either half of this or the square root of this. So in this case, plus 4, right? What about in this case? Minus 5? Because it's a minus 10, right? So we can do half of this or square root of this, but we really got to keep our eye on the sign of that middle term, don't we? Okay, what about this one? Right? Either half of this or the square root of this. Remember how to do binomials, yes? So let's actually solve something with completing the square now, okay? X squared minus 6x plus 4 equals 0. Guys, why don't I just solve this with factoring? Why don't I just do AC and figure out what multiplies to be 4 and adds to be negative 6? Yeah, there's not anything, right? It doesn't always work, okay? So if we're doing completing the square, what do I have to get rid of first? The 4, right? I got to move the 4 to the other side so that I have room to complete the square over here. I'm going to leave myself room right there. Okay? So what's going to go in that blank? Well, divide that by 2 and square it. 9. But now I've completely changed the problem because I added 9 to one side. I do have to add it to the other side. That's exactly right. Okay? If I add it to one side, I have to add it to both sides to keep it equal. Okay? So now from the trinomial, I go to my binomial. What is my binomial in this particular case? X minus, yeah, absolutely. Good job. X minus 3 equals what? 5. Now I'm just using the square root property to solve, aren't I? I square root both sides, here and here. On the left-hand side, I have x minus 3. On the right-hand side, I have plus or minus the square root of 5. And then to solve for x, I just add 3. Remember that 3 can't go in the root sign, though. So I have x equals 3 plus or minus the square root of 5. Are you remembering little by little? So what about this one? 9x squared minus 6x minus 4 equals 0. How about if we have to solve this by completing the square? So I can go ahead and add 4 to both sides if I want to. That's fine. But before I complete the square, what does the leading coefficient have to be? Remember? All these examples that we just did, what was the leading coefficient on every single one of them? 1. Yeah, I have to make the leading coefficient 1 for it to work. So in order to make the leading coefficient 1, I need to divide everything by 9. Okay? When I do that, I get x squared minus 6 over 9. Doesn't that simplify? Yeah. 2 over 3, yes? So again, even if it's a fraction, that's okay. We just divide it by 2 and square it. But if it's a fraction, do we divide by 2? We multiply by a half, right? Oh, this is nice though. Look, if I multiply by a half, I get 2 over 6. Or I could simplify first and get 1 over 3. Well, what's 1 over 3 squared? Square the numerator, square the denominator. 1 over 9. If I add 1 over 9 here, I have to add 1 over 9 here as well. Don't I? Okay. So I have my trinomial. Let's take it to the binomial. What's the binomial? X minus 1/3. Exactly right. Okay. Equals what? Oh, nice. 5/9, right? again, now we're just to the square root property, aren't we? Square root both sides, here and here. X minus 1/3 equals plus or minus the square root of 5/9. But I'll tell you this right now, the computer is not going to like 5/9 like this. The reason it's not going to like 5/9 is because when you take the square root of a fraction, you really take the square root of the numerator and the square root of the denominator, right? Well, I don't know the square root of 5, but I do know the square root of 9, don't I? So this is the same thing as x minus 1/3 equals plus or minus the square root of 5 over 3. Okay? So now I go ahead and add my 1/3 to both sides. X equals, we have two possible answers here. 1/3 plus or minus square root of 5 over 3. Or, since they have a common denominator, can't I combine them? 1 plus or minus the square root of 5 over 3. How are you feeling about completing the square? Terrible? Oh, good. Okay, I thought you said terrible. I was like, oh no. Okay. So, we talked about factoring, we've talked about square root property, we've talked about completing the square. Quadratic formula, ready? Do you remember it? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what if we have 8x squared plus 2x minus 1 equals 0? Before I can even start, I need to identify what, and what. Perfect. A, B, and C. Is it really that important that I pay attention to the sign in front of the number? Yeah. Big deal, right? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay so far? So x equals negative 2 plus or minus the square root of 4 minus 4 times 8 times negative 1. So negative 32 over 16. Everybody with me? What is 4 minus a negative 32? Oh, that's nice. Why is that nice? We know the square root of 36, don't we? Okay, so I can go one more step. Negative 2 plus or minus 6 over 16. And because now I don't have any more square roots, I can go one more step and figure out what the actual solutions are, can't I? I've got negative 2 plus 6, which is what? 4 over 16. Does that simplify? 2, 1 over 4. And then I have negative 2 minus 6, which is negative 8 over 16. Does that simplify to what? Negative 1/2, right? Questions about quadratic formula? Guys, if quadratic formula works every time, why do we make you learn all the other ways? Yeah, it's not always the easiest at all, right? You don't want to get a problem like this and have to do quadratic formula on it, do you? You'd rather just add 25 to both sides and square root both sides, right? That'd be kind of silly, huh? So, let's talk about discriminant real quick. Use a discriminant to determine the number and types of solutions. Do you remember what the discriminant is? Do you remember that it's this part of the quadratic formula? the part underneath the root sign, that's the discriminant. Okay? Not the root sign, but just the number underneath. Okay? There's 3 possible options that the discriminant can be. The first possible option is it can be positive. If the discriminant is positive, there are 2 real solutions. Do you remember that? So if I graph it, it might look something like this. Right? Here's the solution, here's the solution. Or maybe it opens down. Here's the solution, here's the solution. Does that make sense? What's another possibility if it's not positive? It could be negative, right? If it's negative, there's 2 imaginary solutions. No real solutions, but 2 imaginary solutions, right? So if I graphed it, it might look something like this. If it's opening up, or like this if it's opening down. It's not crossing the x-axis at all. Because that's where our solutions are, right? That's where our graph crosses the x-axis. So if it doesn't cross the x-axis, would that make sense that there are no real solutions? But in this case, 2 imaginary solutions, right? What's the other option? It's either positive, negative, or 0. If it's 0, there's 1 real solution that has a double root. Okay? That means if I graphed it, it might look like this. If it's opening up, or like this if it's opening down. It crosses the x-axis only 1 time. Does that make sense? Yes or no? Okay. Just a little bit more. The last one. Determine the most efficient method to use when solving a quadratic equation. Okay? So the first way we talked about was factoring, right? When will we use factoring? Well, to me, it seems the most obvious we'll use factoring is if it's factorable. Right? So if it's a easy to factor trinomial, if we see AC right away, if it's a binomial that's the difference of squares or the difference of cubes or the sum of cubes, we definitely want to use factoring, right? Okay? When will we use completing the square? Most often, for sure, we want to use completing the square if A is 1, right? If A is not 1, I probably don't want to use completing the square. Because if A is 1, I know what to do. I don't have to do any division to start with, right? When am I going to use square rooting? What makes it super easy to solve with square roots? If there's no x term, right? Like x squared equals 25. I don't want to use quadratic formula for that. I don't want to complete the square. I just want to square root both sides, right? There's no x term I have to deal with. Okay? Because then I can just square root both sides. Okay? And last quadratic formula. What's true about the quadratic formula? It will always work. I mean, provided you do the arithmetic correct, right? It'll always work. How do you feel about factoring? Okay. How do you feel about square root property? Good. Completing the square? Yeah. Okay, that's fine. Quadratic formula? Can you look at the discriminant and tell me the number and type of solutions there's going to be? Can you determine the most efficient method to use when solving the quadratic formula? Or quadratic equation, excuse me. Yes? All right. Peace.